Thank you for coming. I know it's hard to want to be out in groups of people nowadays. I want to be out there, but there's always this thing in my head that tells me that I shouldn't be out there. And but I'm happy everyone's here, and it's much nicer speaking to a live audience than it is trying to speak in your office in front of no one. My cat is not that good of an audience, and he's way smarter than I am anyway. So I'm Adam Backman. I work for a company called Whitestar Software. Most of the people know who we are already, but if you don't, we've been around for a long time. We're one of the oldest, and we are the oldest independent consulting group. There used to be a company called Bravepoint, and they got absorbed by Progress at some point, and then dismantled almost. So, we specialize in just database administration. That's what we do. We have a product called ProTop that allows people to get insight onto their system, and we do training, consulting, mentoring for people over time. I'm here to talk about the performance of database read operations. And the database read operations are critically important. People don't think about how important read is to their operation. They say, oh, I do some reporting, and that's very important to us. I do other things, and that's important. But what we're going to do is talk about how do we create the best environment for doing that? How do we create the best environment we possibly can to accommodate all the database reads that we do? We want to behavior, and people don't think about doing this very often. Modify how you do things and scheduling things outside of rote times, meaning don't have the person come into the office and the very first thing they do is run a report. Have that report run before they come to the office so they can just pick it up. Therefore, it doesn't run when everybody else is at the office. The best thing that you can do in these operations, anytime reads, is to do less reads. Eliminate the reads that you're doing. So we'll talk a little bit about that as well. The only reason you keep data, the only reason that you have a database in the first place is to store it so you can read the data at a later time, or somebody else can read the data at a later time. Reads are very much the vast majority of what you do. It's very common for there to be thousands or tens of thousands of reads for every write that you do in the application. So writes are expensive, but they're so much the minority of what you do that reads become paramount, getting them to be able to get to the end user in a timely fashion. Read operations, they're important. Everyone thinks about that one report for a long time. I tend to not think about reads as being important at the report level as much as I think about reads supporting online transaction processing. I think about how we do reads, and if the reads are slow, that's going to slow down how much I can insert into the database itself. And remember the value of the write reads. The best reads you do, the ones that are effective, they're much more important to you. Creating the best environment. And I'm going to talk about how all the hardware considerations, and then we'll talk about database considerations. The biggest thing for me is when I'm building things, people very frequently overbuy CPU. They purchase CPUs and they want, oh, I want 30 cores because I can buy a 30-core chip from Intel right now. Well, I want you to buy chips with fewer cores in them. I want you to buy the chips that have the fastest speed that you can get. So the greater the frequency, the better the chip is going to be. So that's what we're trying to do. We'll talk about SSDs being the standard now. Anyone who tells me that we're buying spinning disk, we call it rotating rust, Anybody who's buying spinning disks these days is spending money in a wasteful manner. It's more expensive, it's slower, it's not good. So what we want you to do is think about SSD. Having if performance is important to you, having the disks local to the CPUs is very important, because what's happening is you're increasing latency by the distance that storage is away from your CPU. So what we want to do, and then everybody's trying to virtualize these days. We'll talk about the best things that you can do to increase the performance of your virtualization. I call it the Aspirin Principle. If I take one aspirin, it cures my headache. Well, why shouldn't I take 40 of them? So one CPU solves the problem. Don't buy another 35 of them. Don't buy another 39 of them. People tend to overbuy the cores, underbuy the frequency. So when I start looking at this, I want to buy a reasonable amount of cores. And what's reasonable? If you have greater than 8 cores, you're most likely well over spec. Most people require less than 8 cores on there. My laptop has 8 cores on it. So everybody out there can overbuy CPU like mad. But the problem is as those cores start increasing, the frequency starts decreasing. Also, the amount of intra-processor communication increases as well. So the overhead inside the chip itself increases, and that decreases performance. And especially on things where I'm going out there and I'm updating the buffer pool, and I'm going out there and I'm flipping latches on in progress. I want those operations to happen as quickly as possible, because every time I do a latch operation, it's potentially blocking other users out there. So if I can do that latch operation faster, I can get through it faster. So there's lots of things inside of OpenEdge that are still single-threaded. There are still plenty of single-threaded operations. They're breaking them up bit by bit over years and years. But if you're running version 10, you get more blocking. Version 11, you get a little less blocking. Version 12, you get a little less blocking. So it's getting better, but it's not a perfect system yet. I talked about this. Again, 8 cores is kind of like our over-under. When I see people tell me that, hey, I've got 30 cores in there, I know they have too many processors out there. And now when you start seeing these very high core counts, the other thing you need to worry about is that you might be in a NUMA environment, which is you might have memory and chips that are loosely coupled, and that's not good. So what we want to do is we want to have things tightly coupled as we can, so therefore having fewer CPUs is a better option. HyperThreading. The things in HyperThreading are, it adds a second queue. It's not adding a second CPU out there. All it's doing is doing the pipeline properly. So what happens is the pipeline is allowed to read 2 things at the same time. So if that CPU were blocked on a resource, the other pipeline could feed it. That's not the same as having 2 different CPUs out there. So when I count them as the number of physical cores out there. I don't ever count threads. They say, Intel says this is a best case scenario that you're going to get a 30% boost. You're not getting a 100% boost. And so many people, and the worst thing is VMware takes every thread as a core. And we don't want to do that. We want to use them in their original state. Some Intel examples of buying CPUs now. The E series, which is the cheapest series they have, generally have 8 or fewer cores. Base frequency, no turbo stuff or anything like that. I just worry about what the base frequency is that I can go out there and I can get things up to 4 gigahertz out there. If I go to the W series, which are much more expensive, I can get 38 cores in a single die. But my speed drops by a great deal. And again, you're never going to be able to utilize all of these 38 cores, 99.9% of you. So give me 6 cores at 3.5 over 38 at 2.5 any day. I'm going to be able to outperform you. So that's the thing, and people just don't think that. They don't think about the speed versus that. There is a W series with 12 cores out here, and base frequency, you can get 6 with even higher frequency. So what we're trying to do here is say, when you're buying, you're not just buying cores, you're buying cores and frequency, and try to buy the best combination of those you can. Why buy solid state disk? These disks out here, the old rotating rust we had out there was capable of doing 190 IOPS per second, or IOPS. Now SSD can do 4,000 at the low end and 300,000 at the high end if it's plugged directly into the bus. So I can go out there and I can grab huge amounts of IOPS out there for way cheaper. So I only have to buy one drive versus having to buy all these other drives. So when I'm purchasing things, I'm buying them for the number of IOPS. They're too expensive. Local versus network. When we think about network disk, we have to think about a lot of things. One, it's more expensive because I have to buy another physical machine that's got memory, it's got CPU, it's got the disk drives itself in it. But now I have more layers to traverse. I have to go across a network layer, which is especially slow. I have to add complexity to my technical stack out there. So it seems like it's not a good deal. There's not anything in that stack that makes me excited about it. But people who are running VMware say, okay, I get these other features with network drives that I don't get from local drives. Well, do you really? And do you use those features? A lot of people who have virtualization don't use any virtualization features. They have it because, you know, my friend has it and I should have it too. And it's like, you know, in our country they always say, if little Johnny jumped off the Empire State Building, would you jump off the Empire State Building too? And the answer is probably because I'm not that smart. But what we want to do is go into local disks. I can buy things that are much, much faster. I reduce that latency because the distance between it is closer. The bandwidth is wider because I'm sitting right on the same bus as the CPU and the memory. And I don't have to think about other hosts accessing it. I might if I'm virtualized and I have local disk, but most of the time I can have local disk that is mine and I own all of the bandwidth of it. I own all the throughput. And that makes it easier to maintain. It makes it easier to tune. So this is a much better solution for most of the people here. Okay, I don't care. Tiered storage. When people go out and they buy tiered storage, it's a way for vendors to sell you more capacity, but actually sell you junk for expensive cost. So you have all these things, but the problem is that you don't want your database to live on any of the junk. You only want to live on the good stuff. So what happens is you have to defeat the tiered storage. And they say, oh, don't worry, it's auto-tiering. Well, it's auto-tiering because it's going to figure out that your stuff needs to be on the busy disk. Well, it will, provided that it's busy all the time. What happens is that you may have different portions of the database that are differently busy, and they'll get pushed off to this slower drive. And you think the SAS rates were bad, SATA rates are even worse. So if anything gets migrated into a SATA tier, you're all of a sudden going to have glacial performance. And we really want to avoid that. So if you have this, the very first thing you need to do is say, I'm going to pin my data into tier 1 or into the SSD storage out there. It won't make your friends happy, but it'll make your users happy. People don't think about this. It's only a nanosecond, okay? Every foot that you are away from the machine is another nanosecond. Well, everyone goes, well, I'm only a few feet away. I'm only a few meters away. Well, if we were doing these operations once, it wouldn't be a big thing. But we're doing these operations billions of times a day. So every nanosecond comes back to be a second in real world time. So now I'm starting to talk about seconds that I lose over the day. And if I have longer runs where I have tens or hundreds of meters out there, And that includes all of the physical wire you have out there, all of the circuitry inside of all of the switches and everything else it goes through. So that becomes a very long path very quickly, and that increases the latency of every request that you do. So what we're trying to do is make sure, if you want to know more about this, we have a white paper on this that shows what the difference is between these things. This is an excellent illustration. Tom did a presentation a while ago, and this was how fast things take. If I go 4GL to directly to the buffer pool, I'll say that's number one. As soon as I can't get it out of the buffer pool, I still get it out of cache. I get it out of the file system cache. That's 75 times worse. Okay? That's just one delta. That's one change. If I go and I have to get it out of the SAN cache, well, it's 120 times worse. If I have to go SAN cache to disk, that's 1,500 times worse. So we really never, if we can. We're trying to hit everything out of the higher value. So when you go all the way down from -B to disk, you have 1,500 times worse performance for that one operation. The fortunate news is that you'll usually get a lot of records when you do that, and it won't last long, provided you have a big B that's large enough to hold all your stuff. Only virtualize if you really need the features. And people say, well, we do snapshots. Well, snapshots are garbage anyway for most people, so you don't really need snapshots. We want to be able to move our things quickly from one to the other. How many times have you done that in the last 10 years? All of these things people don't use. They say they use them, or they say they're going to use them, but they never use them. But if you're going to use virtualization and you have a valid reason, the very first thing you need to know is that you can never overcommit resources. So if you're allocating all of the threads that you have out there, you're overcommitting resources. If you're allocating all of the memory you have out there, you're overcommitting resources. How am I overcommitting resources? I have to remember that it's not free. The virtualization you're doing is adding another layer out there, and that layer costs money. So I have to remember that I have to reserve CPU and memory and capacity for the VM host itself. It's vital that you do that. If you don't do that, you're not going to get that. And again, if you're counting cores, only real cores count. So what about Amazon, Azure, Google? The CPUs are similar to how they work on-premise. I need however many CPUs I need to be able to run my business. The problem is with the storage layer. Okay? Storage layer becomes a very difficult thing to deal with. But AWS has come up with a way that they have something called, they call it ephemeral storage. It sounds really interesting. But what it is that there's actually blocks that you're looking at. So there's a physical disk inside there, and it's very fast. The problem with ephemeral storage is that in theory, you could delete it. But in practice, you're never going to. Because if you would take your machine and throw it off your physical machine and throw it off your loading dock in the back of your office, that's similar to what you'd have to do to get rid of ephemeral storage. The difference between ephemeral storage and EBS elastic block system is that it's tied to the host itself. The other stuff is not tied to the host. So if you get rid of the host, it's still there. Ephemeral storage, if you get rid of the host, it goes with it. So just that's the only thing you need to worry about out there. The EBS is it's durable, but as soon as you need to guarantee IOPS on that, it becomes very, very expensive. And I'm talking about thousands of dollars per month to go out there and get half, at best, half the performance that you're going to get off of ephemeral storage. The ephemeral storage is going to give me 100,000 IOPS. The best guaranteed performance I can get out of EBS is 64,000. and the prices on that are shocking. So you really don't want to be in the business of trying to put your database on EBS when ephemeral's there and much, much cheaper. What I usually do is I take the ephemeral storage, I use that for my database, and I use that for all the active portions of my database, DB, BI, temp files. Then I take the EBS and I use that for backups. I use that for AI archives, those things that are, reliability related. And that way I have a defense against the ephemeral storage weakness. 100,000 IOPS per second is what you're going to get because it's plugged into the bus. It's direct physical storage on the bus. It has nothing to do with a SAN. It has nothing to do with any of the other stuff that's out there. So it's permanent as long as you don't do anything stupid, like delete the host, use it for that, and then use the other stuff for everything else. When you look at this cost, the weird thing about ephemeral storage, you have to buy storage optimized AWS products. And when you look at this, you can get these, but this tells you what you're getting for the ephemeral storage right here. So when I buy things, I can get CPUs, but if I need a lot of storage because my database is quite large, what's going to happen is I'm going to have to buy 32 CPUs, okay? If I buy that number of vCPUs, nobody needs 32 CPUs, so what do I need to do? I need to actually deallocate them at the operating system level. So I'll get the performance that I want by the fewer CPUs that I get, and I'll get the storage that I need by the number of SSDs that I get. So it's a little bit tricky to do what you need to do, but you have to figure out where you fit in this. And if you go up to these larger number of CPU values, you're going to need to be able to reduce them in your at the OS level. Database block size. The simple thing to think about database block size is you really need to go to 8K just about everywhere. Windows is hardwired at 4K, but the performance of 8K seems to be universally better. So 8K is fine. The one thing you need to do is as you increase the block size, you need to increase the number of records per block. Should you use 256 records per block all the time? Because now we have these 64-bit address things. And the answer is probably not. There are some use case scenarios that we found that that's a disadvantage to you. If you ever had to do like a rec ID dump of your database because you had corruption, it could take significantly longer if you had to go through 256 records per every block in your database. So going to maybe 128 might be a smarter, good thing to do. Type 2 storage areas, they're universally better. So if you're not using type 2 storage areas, you should be. I still want a one block type 2 area. And everyone says, well, what's the value in that? Well, there's a lot of value just to going to type 2. The fact that the database clusters the data, that's a good thing. But if I only have one row, I want all the other stuff that the type 2 area gives me, where I have multiple OM blocks. I have a lot of things that are beneficial to me for throughput. So I still want that. So if anyone sees something where Progress is asking for features, ask for the one block type 2 area. But you could choose up to 8, 64, or 512. Generally, it's done by the volume of the number of rows that you have out there. So if you have a lot of rows, having 512 is a good idea. Lower rows could be lower. But just if you went to 8 everywhere, you would still get the vast majority of the benefits of going to a type 2 storage area. So it's a good idea. One of the mistakes that people make with type 2 areas is they split based on how their data is used in the database. So they say, oh, I'm going to put my orders and order lines in one area. Well, that's actually making a bottleneck happen. What you want to do is split them by technical reasons of how big that particular table is, how big that particular the average record size or the mean record size of those records. That's a much better way of doing it. Having index areas apart from data areas, that's a good thing to do, because then you're reducing the potential for bottlenecks and increasing of the data. And then I generally have one area for all the rest. And most people, so a lot of people refer to this as a miscellaneous area. I always like all the rest. And the reason I like all the rest is because it's alphabetically first. When you insert a table into Progress and you don't specify, it puts it into the alphabetically first one. And everybody's alphabetically first one is an index area. I don't know why, but it always ends up going in the area you don't want it to go into. So I always try to name it alphabetically first, so if I make a mistake, at least it goes into an area that is reasonable. The before image and after image files don't generally have an effect on the overall throughput of read transactions, but you want to make sure that you have a reasonable cluster size and a reasonable block size to support the overall health of the environment, so you're not pinning the disk out there. Now, what I try to do is I try to use my idle portions of the day. I had a client, every day they printed out this report, and the report was this big. It was a box of paper, and they printed it out each and every day. And I went, nobody reads that paper. I'll guarantee you nobody reads that paper. So what I did is I printed the first page of that and I put it on top of the report, which we didn't run. And I did that for 90 days. Somebody came up on the 89th day or something and said, hey, this report isn't right. You need to print out today's report. And I said, no problem. It's on demand now. You have to teach people they don't need things, they want things, but that's dumb. So we were able to get rid of 1 billion database reads to supply this stupid box of paper on 89 of 90 days. That's a pretty good return on investment. So what you're trying to do is figure out what to do. A lot of offices have these days that go through, and what happens is people go to the office. They talk about what they did last night. They get a cup of coffee. They go back to their office and they do 2 hours worth of work. Then they talk about going to lunch. They go to lunch. They come back from lunch. They talk about what they did at lunch. They get another cup of coffee. They do 2 hours worth of work. Then they talk about what they're going to do when they go home. So 4 hours a day out of 8 hours a day, you're getting actual work being done. But you can move that other work that people are doing in those 2 hours that they work to other areas. I can move it to lunchtime and do a report during the lunch hour. I can move things outside of that so I get it there before people come in. Manufacturing and warehousing generally have 2 or 3 shifts. You can do it before the shift change, so what happens is the next shift comes in and their reports are already done, rather than running them at the beginning of the shift. The problem is if something goes wrong with running those reports, they're not ready, and if you ran them in advance, they can just start up and get going. So it's more efficient in terms of human activity, but it's also much better in terms of the system activity, and that's what we have to think about. Moving things from there, I take my daily reports and I want them, if I have things that go off in the day, and Kathy comes in and she runs this report every day, first thing when she comes in the morning after she's had her coffee and talked about yesterday, what she did yesterday. What I try to do is I have that run before Kathy comes to the office, so it's already printed out. I need all the audit reports. You need to audit all these reports that run frequently. Everything that runs on a daily basis or multiple times a day, they need to be looked at for their efficiency. I don't care so much about a weekly report, how efficient it is. It runs once a week. I don't care so much about even a daily report because it runs once a day. But something that runs multiple times a day, I want it to be very efficient. If you have replication, you can move reporting onto the replication target. And that saves you a whole bunch of IOs on your primary system, and that's a great idea. And then automate reports, the scheduling, production, the report that Kathy runs. Now, overall, the goal here when we're doing reads is we're going to try to move them to the fastest resource. So I'm going to move them off the network and move them onto local. I'm going to move them from local and move it into memory. Then I'm going to move it from memory onto the CPU. Once I've achieved a CPU bottleneck, I'm done, because I can't go any faster. So that's what we're trying to do. So I'm moving things from slow resources onto fast resources. Use the slow resources more efficiently. So if I have to use slow resources, I should use all these prefetch parameters. I should use a larger message buffer size to be able to push the stuff across the network in a faster manner. So if I can't take it, if I don't have app server, if I can't have this run in batch, I can't do something else to make it run local to the box, then at least make sure that the client that's running it has all of the benefit that it possibly can have in terms of performance out there. The best solution that you have out there is don't do reads at all. I don't want to read anything, so what happens is I want to use indexes. The better I use indexes, the better the results are going to be. I'm going to get them faster. Don't do things that are silly, like can find on things where you go, oh, can I find the first one of these and it's not indexed? Well, it was not, at first it was not supported. Then they said, we'll support that kind of behavior. And I'm like, well, why would we support people stabbing themselves? But for some reason we did that. They've made it a little bit better recently. But when you're doing this tuning of your application, you need to start with things that run frequently. And I went to a client site and they had this performance problem, and they said, oh God, everything's horrible. So they went through and they're looking at all these reports and everything like that. And I walked into their operations center, and they have this big operations center where they have a whole bunch of people and you can see everybody. And everybody there is sitting there waiting and angry and shaking their head. And one guy is like, and he's going fast as crazy. And I walk over to him and I said, what are you doing? He goes, oh, I'm just entering orders. And I'm like, well, nobody else is. And he goes, why do you go fast? He goes, oh, I figured out if I put a 1 in this field, it goes really, really fast. So they had the leading component of every index was this one thing, but it wasn't mandatory on the field, on the screen. And everyone goes, we only have one zone, so I don't care. They didn't put it in. He figured out if I put number 1 in that zone, everything went really fast. So instead of having to go out there and change all this other code out there, we had to do one change that says, just push 1 into that field on that data entry screen, and that but that's something that was running all the time, and it was affecting everybody, but only one person had ever figured out how to solve it. Using temp tables of things that you're going to reuse rather than going back and refetching them every time is incredibly important, making sure that you have that going for you. Watch out for really complex where clause. Understand how to use and or, especially if you have things in brackets out there. These are things that you can visually see in the code and know that you may have a problem there. So that's how you find stuff. One of the things that you can do is you can look at polling programs. Anything that goes out there and rechecks for, are these reports run? Are these orders entered? Are that kind of stuff. Any of that stuff that polls over and over again, make sure that it's polling properly, that there's proper pauses in there, that it's not going out there and overrunning the system. Use ProTop to go out and find this stuff. ProTop can help you find the heavy hitters on your system very, very easily. It has a programmer mode out there. It's free. You can download it from our website. And it allows you to run a program, zero the stats out, then run the program again, and you can run through and make changes and see if you request more rows or less rows, and it makes it very easy to find out where the problems in your program are. Okay, running efficient application is the best solution you can have. out there. And a lot of us don't have control over that because we're database administrators. So what we want to do is be able to point to the places that are having the greatest impact. And that is, a lot of times we can just look at something as simple as Promon, looking at the ones who have the billion requests and say, that's our guy. Let's go figure that one out. Build yourself the best solution you can of fewer, faster CPUs, local SSD rather than network storage. Use ProTop to help drill down onto programs to find out which ones are the most efficient, and then move stuff off hours. Be creative, or eliminate things that run every day that don't need to be run every day. And if you need to simplify it even more, the good in scheduling. The better, move work to the faster resource, buffer pool, all of that going out there. And what buffer hit rate do I want to get? Well, I would like to get 100%. But if you think about it, even a buffer hit rate of 98% sounds pretty good. But if you realize that a 99% buffer hit rate does 1/2 of the number of reads that a 98% buffer hit rate does, keep striving to get a higher buffer hit rate. Keep moving up. And then don't read records at all. If you cannot read records at all, that's the best way to improve read performance. Questions? Comments? Personal problems? Please refer them all to Paul. Thank you very much. It still will go down the index tree, and so you're going to get a lot of index entries. So if you're looking at it in ProTop or Promon, you're going to see index entries versus record reads. So they're right that it doesn't read records, but they're wrong that it doesn't impact, or the thought that it doesn't impact people. It still has a big impact, especially with large indexes, things that are very largely indexed. Anything else? He's asking this chat. Anyone local? You can also do, yeah, then it would have to do a table scan to do that. To support a unindexed can find, it wouldn't be able to just go through there. It would actually have to read the records, and you do a table scan on that. But most people are, at least will be able to have some index bracketing happen, and then the stuff that would be bracketed will be index reads. The stuff that can't be bracketed will be physical reads, because it'll have to it has to read the rows. More questions? The chat's a couple of seconds behind. Okay. Excellent. Thank you.